Well, welcome everybody to today's Workflow 4.0 webinar. My name is Kevin Williams and I'm going to be filling in for Kevin Corbley as the moderator for today's session. This webinar's title is As-Built BIM and Urban Renewal, Case Studies in Mixed-Use Redevelopment. And we've got some terrific presenters today, so it should be a really good session. So here's a brief overview of today's agenda. I'm going to start off and just give you a little bit of context about the presentations that you'll be hearing, talk a little bit about the goals, and then I'm going to introduce our panelists. And the first presentation that we've got today will be a rehabilitation project of an historical Coca-Cola building in downtown Los Angeles. And that will be done by Canon Corporation. And then the next one will be done by Cristina Arriaga with Zostak, and she'll be talking about an urban hub redevelopment project in San Juan. And then afterwards, hopefully we'll have some good time at the end to ask some questions of our panelists. So let me just briefly set the context for these two presentations. If you've paid attention over the last several years, you've probably seen a trend of people moving back into cities and rejuvenating urban centers. And a lot of these urban center rejuvenation projects involve a lot of mixed-use land redevelopment projects. And for the laser scanning and reality capture community, this presents a really big opportunity. In these redevelopment projects, they typically face a number of challenges. Often these buildings are being repurposed for something completely different from what they were originally designed for. So you'll commonly see factories being repurposed to be apartment complexes and things of that nature. And so to do that, it requires very good, accurate, as-built documentation in order to do the design and planning for that. And as you probably can guess, there's never ever any usable documentation for these types of projects. You're very lucky if you find hand-drawn documentation, if that even exists. And there's, on top of that, there's all these historical preservation requirements in a lot of these projects. And so if you look at these challenges, you can see some pretty big opportunities for us as laser scanning professionals in this community to come in and help these developers solve these big challenges. And so that's the backdrop for the presentations that you're going to see today. Just a few ground rules. I'm going to keep everybody muted during the presentation except for the presenters. But I still want to keep this as an interactive session. So please, as questions come to mind, please type them into the chat or the question box on the GoToWebinar session. And then after each presentation, I'll ask a handful of questions to our panelists. And then at the end of the entire session, we'll have I'll get to any questions that we haven't been able to get to up to that point. And so you'll have the opportunity to ask these guys any of the questions that come to mind. This webinar is being recorded, and you'll each receive a link afterwards to download that recording. And then finally, I'd be remiss if I didn't remind everybody to subscribe to Workflow 4.0. That's our e-newsletter for keeping everybody in touch and for sharing information and ideas. So with that, let me introduce our panelists. First up, we have Les Carter, who is the Survey Director of Canon Corporation. Les, can you please tell the audience just a little bit about yourself and your background?
Yes, thank you. Yeah, I started surveying through the Southern California apprenticeship some 38 years ago. Had a tour with the Marine Corps for 4 years prior to that. I was with the City of San Diego for 26 years. I've been at Canon for the past going on 10 years. We have a full service survey division with offices in LA, San Luis Obispo, and Bakersfield.
Excellent, Les. Next, we have Zoltan Naj, who's a senior structural designer with Canon Corporation, and he's going to be co-presenting with Les. Zoltan, can you please give us a little bit of your background?
Yes, I started in the drafting and design world about 20 years ago, and I've had experience with many disciplines, not just in mechanical and different engineering background. But I've been with Canon for about 7 years, and here I get to work with all the new toys, meaning Revit and point cloud, not processing the point clouds and extracting information from those. So I got to use some of the earliest Edgewise tools and test them out, and that's why we're here today.
Perfect. Yeah, this is a fun field to be in for sure. Lots of toys. Next, Cristina Arriaga, who is the BIM coordination manager for Zostak. Cristina, can you tell us a little bit about your background?
Sure, thank you, and thank you for the opportunity. I come from a design background. I studied architecture in California. I've had about 12 years of experience in the construction and design industry, and about 10 of those years using Revit. The 3D scanning is newer to me than Revit, so it is still a nice, neat toy, like Zoltan said. And I'm learning a lot through the process. So I think that'll be useful when we think about these case studies, how different people are immersing themselves in new technology.
All right, thank you, Christina. And then finally, myself, Kevin Williams. I'm the chief scientist at ClearEdge 3D. And so let's get started. Les, I'm going to let you take it away and talk about this rehab project with the Coca-Cola building. I'll give you the mouse.
Are we good to go?
There you go.
Well, thank you, Kevin. Yes, we've worked for the developer on a number of projects, and this project came up actually last year. But before I get there, a little background on Canon quickly. We are truly a full-service engineering surveying firm since 1976. We have a full range of survey mapping, scanning, GIS, and most recently the UAV or drone mapping. We like to consider ourselves all things 3D at this point in our development. We do have civil, structural, mechanical engineering divisions. We have an instrumentation, electrical, SCADA group. We do permitting, construction, grant funding assistance. And as I mentioned earlier, we have offices in Los Angeles, Bakersfield, and San Luis Obispo. I'll go on to the next here. A little bit of a delay there, I guess. Okay, the old historical Coca-Cola building. The laser scan and Revit model, that was our scope of work for providing a precise as-built for retrofit of the historical building for a multi-use commercial and residential development. The building is a basement and 3 above-ground floors and roof, approximately 150,000 square feet. Our deliverable was a fully featured 3D Revit model, and Zoltan will elaborate on that a little bit more. The time frame for the project from scan to delivered model was the 30 working day schedule. The scope of work specified detailed modeling of the interior walls, floors, ceilings, columns, and MEP features. Bit of a delay. Unique challenges. As you mentioned, that often in the urban retrofit and repurposing of older buildings which have no as-built drawings, the current scan or point cloud model or Revit model become the as-built. And the specific challenges for this project, we had very poor lighting in the basement, so we brought in a couple of construction lights, very bright 2400 lumen battery operated LED lights. They worked very well. Positioned those at the base of the scanner when the scanner was operating. Transferring our XYZ coordinate control from an exterior baseline up and onto each floor of the building and down into the basement, so we had contiguous control throughout the building to tie everything together, ensuring sufficient overlap between over 150 point clouds for the interior of the building. And highlight, it was just the interior of the building. There were some material stockpiles and some minor debris that were still in there, so rather than worry about getting a clearing crew in, we just cleaned those up when we prepared the DTM and tin surface for the floors. And then also it was quite challenging to model the fine details of small diameter piping, conduit, and the uneven floors, which Zoltan will showcase shortly. A bit of a spin there. The photos on the right side of the screen highlight, I think the upper is, you can see how dark and dimly lit the basement area was. And then on the upper floors, there was a little more light coming in, natural light coming in, didn't require any additional lighting to be brought in. Our field equipment was a Faro X330 scanner. We registered the point clouds with the Scene software, and we end up cleaning up the digital terrain model for the floor features in a combination of Civil 3D and Cyclone software. The logistics for the project were preparing a site scan planning map, determining horizontal vertical control datums to be used, planning the logistics to tie into NGS published control for NAD 83 coordinates and NAVD 88 elevations, determining, estimating the location number of anticipated scanner setups to ensure the necessary point cloud overlap of the desired building features and details. And this all went into the basis for estimating the overall field and office processing costs and identifying a workable schedule. Initial site recon to confirm the existing site conditions was very valuable. Before we brought the scanning crew on site, we had a couple of our staff go and meet the project manager. We wanted to assess any obstructions because the scanning is line of sight. Fortunately, there were no drop ceilings to be removed. Again, there was minor debris, the lighting that we needed. And just a note, we used a Rico Theta 360 camera to capture the initial site recon, the site visit, so to use that as a planning tool as well. The building was in close to ideal condition for scanning operations, so we were able to get started with the field scanning fairly quickly, in that it was fairly empty and with limited stockpiles of debris. And let me know if I'm going too fast here, trying to move through it. Okay, field collection workflow. Again, we had a field crew staff of 3. We located and tied in the horizontal vertical control. That took a day. The number of scan setups was, again, I think it was over 150 when all was said and done. And that included the roof, the basement, all floors, and the roof. The collection time was averaging about 20 minutes point to point for each setup, and that included a full 360-degree color photo. Total about 70 hours for field effort. The registration software was Faro Scene. Other field collection tips. The key for us that we kind of a lesson learned was ensuring that we had more than the minimal overlap between individual scans to make sure that everything stitched together and registered together well. But we had some help with that along the way as well. Talk about that a little later. The office modeling workflow was a very rigorous point cloud registration process, doing several iterations of free or cloud-to-cloud registration, and then a partially target-controlled processing as well, and then an actual detailed QA/QC review of how the clouds fit together, in addition to the reporting that Scenes provides for the tension measurements between the clouds. The data storage was tremendous on this project. Our IT group had to allocate some terabytes of local workstation space and ensure we had backed up space on our server to ensure the data was protected. The registration and modeling team, that was our CAD manager, Jason Harless, and Zoltan Naj, kind of in tandem, working between the registration and modeling efforts. Other challenges encountered, working with shared coordinate systems in Revit and Civil 3D. I mentioned our coordinate horizontal control was NAD 83 coordinates and NAVD 88 elevation datum, and the data interchange between our base data and getting that information into Revit was accomplished using shared coordinate systems in Revit, and the skills of two very talented and dedicated team members in getting a fully geo-referenced Revit model completed. And along that path, edgewise, saved us significant time. Objectively, we observed it saved quite a bit of time. Okay, I'll try to go to the next slide here if I can get ahead of myself. Here we go. At this point, I'm going to hand it over to Zoltan, and he can elaborate on some of the features of bringing the scan data into Revit and creating the Revit model.
Yes, first what I would like to say is whoever is doing the modeling should be someone that has experience within a given field. For example, someone who has experience modeling pipes is not the ideal person to model a building, for example. Because then you can fill in the blanks better based on your experience. You make better assumptions. But one of the things the architect wanted was detail of the floors, and because the floors were uneven, so they needed to know where to fill in and where to demo. And with Edgewise, we were able to extract a tin very easily, and in Civil 3D, Jason cleaned it up before we imported into Revit, but you can do that in Revit also, but it was just easier for us to do it that way. But the image below is right from Edgewise, and the result was we created a topo object for each floor that the architect could look at and use in their plans. We also created a Revit floor object, which was just a flat representation. So they had a floor object and they also had a topo object for each floor. And that gave them all the rich information they needed.
It takes just a moment.
And here we modeled all the concrete features and the piping. So the image above is a picture of an actual point cloud image, and the result was below. You can see the same perspective rendered from Revit, and we used the edgewise to extract the floors, the walls, and the piping, and we manually had to model some of the ceiling features in Revit. And one of the tricks I learned in edgewise is sometimes you don't have a complete point cloud, or you don't have a wall in a certain place, but you know you need one. I was able to copy a wall and then move it over and then extract another wall in the original location. So you can kind of create objects in there that kind of just a way that you can use the program that isn't exactly possible any other way. So I was able to use that trick to create things in there that where we didn't have point cloud information to extract from. So here we broke the project up per floor. We created a Revit model for the basement and each floors, and then one for the roof. And then we brought them all together into a host project using the shared coordinates. And it went pretty well. We were able to bring in all the walls and then cut in the openings with the edgewise. Once in Revit, that's where we did the cutting of the openings. And we had another model that had just the pipes, and we brought those in separately. And it saved a lot of work. On another project I did several years ago, we used AutoCAD and without edgewise, and there I had to manually cut sections through the cloud, draw polylines, and extrude everything, and it took a long time. But
I was just going to highlight the project that Zoltan mentioned several years ago was the Caltech Lind Robinson Laboratory in Pasadena, a similar retrofit and upgrading to that building, which is now a state-of-the-art facility in California for scientific research. But in the past 3-4 years, it's come quite a. We wish we had edgewise then. That's what I wanted to say. But these numbers that we've summarized here for productivity and time savings are as not optimistic. They're as conservative as we could make them in our observation of what would otherwise been a conventional or old workflow, and this most recent opportunity to observe the time savings using edgewise.
Thank you. So we had an aggressive schedule, and that was one of the reasons we broke up. I was focused on the floors and the architecture, and then and Jason, who also did the point cloud processing and registration, he used edgewise to do the piping and the mechanical. So we had a pretty aggressive schedule. We did a floor by floor, and we just went through systematically. That was one of the key things, is to first do all the walls, do all the columns, do everything that's the same in a production manner. One of the custom things we had to do in this one in Revit, I created a custom ceiling objects that are reusable and adjustable per the point cloud in Revit. So that was interesting, and got good results with that.
So I think we're close here for tips and tactics. Certainly a preliminary site recon was very valuable to us. We didn't have the opportunity to take the the scanner in a preliminary mode, but we used the Rico Theta 630-degree camera, which is very helpful. Important that the scanning crew has complete access to all areas of the site when they mobilize, or that we know that prior to mobilization, so they can move through the building or facility fairly efficiently and without being restricted by obstructions of any or access issues. And that there is adequate lighting, because our resultant product is a fully colorized scan cloud of the building. Determine if shared coordinate systems are needed, what the coordinate basis is, what the coordinate elevation datums. Essential to identify that right up front. For the deliverables, for the design team, what datum do they need the deliverables to be in? And this certainly will make data interchange much smoother and ensure compatibility across the likely multiple software platforms that the project team is going to be using. It was very helpful to establish a secure FTP site for sharing the data. With the Faro Scene web share, we were able to provide the client with access to viewing the actual scan point cloud data. Having a cloud-based system for that data interchange has to be set up, has to be established, but that is a feature of the Faro Scene software. And that we talk about real-time data sharing, but this was an exercise in the execution of that for not only the team members at Canon, but for our client and for the entire design team, the architect, the engineer, the development team, Del Amo Construction. So that really helped. And I think we've come to that transition. So back to you, Kevin.
All right, fantastic. Thank you, Les and Zoltan. Quick question before we move on to Christina. One of the questions that came up from a couple people interested in the registration method that you used. Did you use spheres or targets or targetless registration? How did you end up doing that?
It was actually a combination of, we had controlled targets. They were flat surface, I think 4-inch, 3.5, 4-inch diameter flip targets that XYZ coordinates were placed on, and those were used to constrain the cloud-to-cloud registration or fix those clusters, those point cloud clusters on each floor to establish XYZ coordinates. I mentioned earlier that there was an iteration of a cloud-to-cloud registration. It was subsequently constrained to, that cluster was then constrained to the target XYZ values that were spaced throughout each floor, and that registration was challenging but successful and achieved a redundancy of observing the accuracy of our relative accuracy being within the observed tension that we were looking for our deliverable accuracies of plus or minus 3/8 of an inch.
Okay, perfect. Well, let's move on. Christina, can you tell us about your Urban Hub redevelopment project? Christina? Do we still have Christina?
Hi, I'm sorry. I was muted there.
No problem. Take it away, Christina.
Okay. I'm going to need the mouse. So a little bit about us, about Zostak. We are a construction management company specializing in the implementation of new technologies. And when we talk about new technologies, we've heard a lot about what BIM is, Building Information Modeling, and what we're going to be talking about today, which is 3D scanning. We try to implement and introduce these methods for construction projects and present it to our different types of clients in a way that they can use this new technology from the planning all the way to the operation phase of the project. Our clients include owners of projects, architects, consultants, engineers, general contractors, and subcontractors. We actually started heavily with general contractors at first. I think they saw the benefits of this technology even before anyone else because it resulted in savings for them during construction. And our team is made up of architects, engineers, drafters, and project and engineering managers. This particular project is in the heart of our downtown in San Juan, Puerto Rico. The owner of the project is our client, so a little bit different maybe from other types of scanning jobs. The project is made up of a few different areas. There's the retrofit of an existing 50-year-old multi-story parking structure to house a green roof plaza on the last level. So that last level is about 3,200 square feet, but we actually scanned the whole multi-story parking structure because to incorporate that green roof plaza, we had to get a detailed model of all of the MEP in the whole parking building. The building was made up of a basement, two above ground floors, and then the existing plaza level, which is right now, which was originally a parking lot and was going to be turned into a green plaza with a steel pergola on top. The other aspects of the project were a pedestrian bridge, which would be linking this existing building to the other side of the street, to a new developed lot, and eventually all the way over to the metro line and the Coliseum that's right next to the metro line. So it's the idea of the project was to link all these transportation hubs all together. The pedestrian bridge is about 6,720 square feet. It would be linked to a new built space, which is a restaurant. The restaurant would be a tenant of the owner. And around the restaurant, there would be an urban park of about 2,200 square feet. The level of detail that we needed to provide in our model was 400. And the scope of our modeling was to provide project management support using BIM for the whole process of the design and construction phase. So design and constructability reviews. We also did renders, animated video, clash detection, 4D visualization, 5D costing, and quality control. As you can see in this aerial picture, I think I hit the button, sorry. As you can see in the aerial picture on the lower left-hand side, the existing building connects through the street to the metro line. One of the challenges in this particular redevelopment project was turning this urban development into an investment for the owner in terms of scope, time, and cost, because it is a privately funded public space project. So some of the things we were able to make clear to them through the use of this scanning technology is that, for example, we could provide the as-built drawings, but then also once the new construction was modeled using the 2D plans from the architect and the structural engineer, we could then come in and rescan the newly built steel structure before the erection of the metal cladding, for example, and that would offer significant savings to the owner. So that was those are interesting things that we can do with scanning, not only as built, but also through the whole construction and design phase of the project. The data collection in this case was interesting. The interior of the multi-story parking structure was pretty easy because we were able to coordinate with the operation and maintenance division of the owner's building to have them empty out each floor. So we had full access to each floor. The exterior was a little bit trickier because we ended up scanning the two whole avenues and two whole busy avenues, so we had to start at 5 a.m. And sometimes ended up working until 7, 8, 9 p.m. To get these exterior scans. We also had to deal with heat noise for the exterior scans. We are on a tropical island, so the scanner is sensitive to the heat and the noise that heat gives off on the asphalt. So from 10 a.m. onward for these exterior scans, we had some issues with the heat. Like I said, we had to make sure to coordinate with the maintenance and operation department for scanning. The owner in this case is a well-known local bank, so they also had some security concerns. So we had to make sure that all of our moves were well explained and planned out beforehand. The field collection workflow that we use is that we like to do a walkthrough first to know what we're getting into, more or less. We also, for this particular project, had to study our target placement and what our target placement would be. We ended up, it ended up taking us about 2 hours each day just for target placement. In the exterior, we did use wall-mounted paper targets and spears. Since the avenue was quite wide, about 45 feet of avenue, that gave us some challenges in terms of target placement. We also like to mark on a location plan, on a site plan, those targets, number them, and make sure we know exactly where we place them. And then we also like to take some strategic manual dimensions. In the interiors, for example, we always like to take a few height dimensions, some dimensions between point clouds, just so that we can do that double checking afterwards. During the pre-planning, like I said, it's very important the setup of the targets. The challenges that we have with targets are that if they're moved or tampered with, we have to discard them because we need at least those 3 common targets within a scan. We also, it was challenging in this project to limit the distances between scans because of that wide avenue. We ended up having to do many scans and then some long scans just so we could get the whole avenue together. Also, some of the challenges are understanding the project scope. That helps during the planning. We always need more scans in areas where more details are needed. In this case, the basement, for example, had a lot of piping. We had to do a lot of correct, accurate MEP there. So we ended up doing very detailed scans of the basement. And then the georeferencing. We were lucky in this project that the owner had already coordinated to have some benchmarks set up, which made our georeferencing much easier. We were able to tie into those benchmarks and then just take the survey points of the targets. And that helped us also during the georeferencing, not only of the point clouds, but of the whole Revit model. We did use shared coordinates in Revit, like Cannon mentioned. Our workflow in terms of number of scans in the interiors, we ended up doing about 80 scans per floor, which is a 2-day per floor collection process. At the exterior, for the 2 big avenues, we ended up doing about 100 exterior scans, and that was about 3 days of collection. And the point clouds were registered mostly through Ferrocene. We did do some cleanup in Recap. We were testing out Recap Pro as well during this process, and we ended up doing a little bit of registration using Recap Pro. I've included a table of some of the best practices for point density in terms of distance and resolution. So as you place your scanner further away from your